In this video, I'm going to show you how to multiply radicals and simplify radicals. So let's get started. First of all, think about this problem, square root of 2 times square root of 3. What would you like that to equal? Well, I think most people would say, hey, let's multiply the 2 and the 3, and let's call this the square root of 6. So it turns out that's how this works. Notice here it says if the square root of a and the square root of b are real numbers, then the square root of a times the square root of b equals the square root of a times b. So this is how we multiply square roots. Now you might wonder why. We could actually write each of these as, this would be a to the 1/2 power times b to the 1/2 power, and the right side would be ab, my radicand, to the 1/2 power. And in fact, these are equal. Just using the property of exponents, we called it the expanded power rule. And so it's really the rules of exponents that justify this multiplication. Now in general it says if the nth root of a and the nth root of b, I forgot to say, are real numbers, then we have the nth root of a times the nth root of b equals the nth root of a times b. All that's saying is our root doesn't have to be a square root. It could be any root. And the proof would be similar to what I showed you up above. So for example, if you had the cube root of 5 times the cube root of 6, you just multiply your radicands, that 5 and 6, and you get the cube root of 30. So what we're really saying here is we can multiply radicals that have the same root or the same index. Alright, so let's go ahead and do some problems. Square root of 3 times square root of 11 is square root of 33. Square root of 2x times the square root of 3y, we just multiply the numbers inside, we get the square root of 6xy. Now notice number 3, and actually 3 and 4 are kind of a special case here, but an important case. When you multiply the square root of 7 times the square root of 7, you could write that as the square root of 49, which we know is 7. So square root of 7 times square root of 7 is 7. Interesting. It's not surprising though, because what we really have is the square root of 7 squared. And we've already discussed how square roots and squaring, or squaring and taking a square root, are opposites. And so you would get 7 here. And so that is our answer. So I don't really need to do anything. I just need to know that when I multiply the square root of a number times the square root of the same number, I'm just going to get the radicand as my answer. So on number 4, we're just going to get x plus 3. So this is an important one to remember when we move on later to some of the things we'll be doing. Alright, let's talk about simplifying radicals. Notice it says a square root is not considered simplified if its radicand has a perfect square factor. Now I think most of us can relate to simplifying fractions. This process of simplifying radicals is quite different, but the whole purpose is kind of the same. In the end, we want to make sure that when we get a radical answer, that they all look the same. And so we simplify our radical answers. So if we look at the first problem here, 18. Now, as we look at the perfect square factors, we don't consider 1. That won't help us to do any kind of simplifying. But we want to look at these other perfect squares to see if any of those are divisors of 18. Well, of course 9 would be. And so we can, so first of all, this radical is not simplified. So what we do is we write this, as, let's do this here. Oh, there we go. Okay, so square root of 9 times square root of 2. So we can break this down into a product of two radicals, but we have a perfect square in the first one here. The square root of 9 is 3. And so we get 3 square roots of 2, which means 3 times the square root of 2. And so that's the simplified form of the square root of 18. Well, what about the square root of 20? Well, if you look at our list, notice the 4 is a factor or divisor of 20. And so we can break this into the square root of 4 times the square root of 5. And we know the square root of 4 is 2. All right, then we look at the next problem. Now, first of all, that negative out front just tells me I'm going to have an answer that's negative. Let's first take care of the radical, and whatever we get, we know it's going to be negative. So we do have a negative, and then notice that 9 is a factor of 27, and so this is not a simplified radical. We'll write it as the square root of 9 times the square root of 3, and of course the square root of 9 is 3. So our final answer is negative 3 square root of 3. On number 4, if you start going through here, you can see, let's see, 4 doesn't divide into 50, neither does 9, neither does 16. Hey, there we go, 25. So let me do this. So basically, we could write this as the square root of 25 times 2, which is 5 square roots of 2. Now when we get to number 5, it's just a little bit, there's a little bit more to it. Notice 4 is a factor of 48, so I know for sure this is not simplified. So let's write this as 4 times the square root of 12. But we have a problem here. Do you see what's wrong? Well, look at the square root of 12. Isn't 4 another perfect square factor here? And so we don't want to do it this way. We could actually work with it the way it is, but it's just easier to move on and look for the bigger factor. There's a bigger perfect square factor. All right, so we're going to just start over here. Turns out that if we keep going, 9 doesn't work, but 16 does, so we can write this as the square root of 16 times 3, and we get 4 square roots of 3. And of course, 3 doesn't have any perfect square factors, so we're certainly simplified completely. All right. So now our numbers are getting a little bigger, but that's no problem. You can divide 96 by 4, by 9, by 16, and actually 4 works. So look at what we have here. And we have the same issue we just had on the last problem, because 24 still has a factor of 4 in it. And so this is not going to be the one that we're going to want to do. Again, 16 turns out to be the larger perfect square that works. And notice the 6 has no perfect square factors, so this is what we want to work with. And we're going to get 4 square roots of 6. So go ahead and try number 7. It looks difficult because the number is big, but you just need to keep going until you find the perfect square factor of 294. So you might want to stop the video and try it. All right, you should have found that the square root of 49 works, or 49 is a divisor. So we can write this as negative square root of 49 times square root of 6, because 6 times 49 is 294. So we're going to get negative 7 square root of 6. Now, sometimes students get into a rhythm with these type of problems, and they'll do some interesting things, like here maybe square root of 2 times square root of 7. The only problem is neither of those are perfect squares. In fact, 14 doesn't have a perfect square factor. 4 doesn't go into 14, and neither does 9. So that is not going, this one's not going to be needing any more work. It's already simplified. And then on occasion you might run into a problem like 9. Well, 100 is a perfect square, so there's no work to do here other than just to take the square root of 100, which is 10, since 10 squared is 100. So as you're looking at a lot of different radicals, they don't always simplify. Sometimes it's already simplified. Sometimes you're dealing with the perfect square. You just want to be careful that you're paying attention and doing whatever's necessary to get a final answer that's simplified. And that's the end of this video.